So my story begins, or this story begins in 1989. That's when I got my first computer. And as you can see, basically, what you got when you booted that computer is a prompt. So if you wanted to do anything, you basically had to learn some programming. And this is how I learned to program, and I really enjoyed doing that. A few years in, it's time to get a job, or it's time to prepare for a job. The problem is, I still enjoyed programming. I had learned, I had picked up a few languages, and I really enjoyed it. But at this time, being a programmer in Stockholm, Sweden, it meant having done 4 years or more of university math and physics. And problem is, I was not very good at math and physics. I just couldn't do it. So I hated that. So I gave up on that dream, and I felt like I was an idiot. And of course, I think I still do at times, and I'm sure I'll share that sentiment with some of you too. So, where does all the idiots go? Any ideas? Yes, of course. I was in the army. I started doing conscript service for a year here in Sweden. After that, I was 6 months in Liberia, in West Africa. And I was not a very happy person at that time. But at least I was not the worst idiot in that group of men. So the years following that, I don't really know what I'm doing. I'm just trying different things out. I studied political science here in Stockholm, who prides themselves on being on the 176th place in the world university rankings. While I was doing that, I was working extra in a shop. I was selling hi-fi equipment. And eventually they offered me a full-time job. I dropped out of university to pursue that. Eventually I became a shop manager, and I managed a shop with a staff of about 10 people. So, and this was still at a fairly young age. But still, I was not very happy. One thing that had happened in those years, though, is that this concept of being a programmer changed. Because even if these ads are from now, all of a sudden you could see this on the subway, or you could hear people who went on like a 3-month boot camp. They came back as programmers. And that was simply not a thing a few years before. So eventually I burned out doing my shop manager duties. And I sent out an email to like 100 companies saying, like, I have nothing to show. Like, I love doing this. I have no experience to show you, but I can work for almost no money. So one company eventually replied. They said, like, hey, you can try. And I got my first developer job, which, true to their promise, paid almost no money. This is so I got, and this is before taxes. I still have this paper. I had lost it, but I sent them an email. So it's like, can you send me this? And they were like, yeah, sure. So I still have this now. And I was in fact making so little money that I had to borrow money from mom just so I could afford to work. But I was happy because I was doing what I wanted. And now 15 years in software, I have never still had to do any math. So that was a weird, odd requirement, wasn't it? Oh, so are we going to stop here about Anders? Yes. So meanwhile, as I was getting into this industry, Tim Hinrichs does the first commit in the Open Policy Agent codebase. And of course, I have no idea at this time what that is. But some actually smart people, they had been building policy engines at various companies. And after having done it for a few times, they were thinking like, hey, wouldn't it be good if we didn't have to do this from scratch every time? Could we not just use the one we wrote the last time? But of course they couldn't, because that was for another company. And at this point, I still had no idea what a policy engine was, and perhaps neither have you. So let's start there. So the basic idea of a policy engine is basically it's a program that makes decisions based on rules and data. So you have an application or a client which sends a query. It basically asks a question. I have a developer here. He's trying to read a report. Should they be allowed to? And the policy engine, based on the rules that you have provided, such in this case, like admins can do anything. If you work in finance, you can write reports, and you can read reports. It returns a decision. In this case, it would say no. And reading this or hearing about this, you might think like, that's just an if-else condition, or it's just a bunch of if-else conditions. And you'd be right. That is basically what a policy engine is. It's a way to do this at scale. Because just nesting hundreds of or thousands or hundreds of thousands, if you have a fairly or a sufficiently complex environment, it doesn't scale very well. It isn't very pleasant to read. It's not pleasant to write, and it isn't composable. You can't just move around these if-else statements, or at least not very easily. So the basic idea is that you decouple this from your applications, which allows you to manage these policies separately. And it also allows you to share them across applications. So if you have a whole bunch of rules, and you have some apps written in Python, some in Java, some in C, or whatever, they can all share the same policy through this policy engine. So now you know what a policy engine is. But back in 2015, these people already knew. But still, it wasn't their invention. Like, people had been doing policy engine. They had been doing policy engine. So what was new? Or what changed? Well, you changed. Or that's the reason we're here. Because the world is basically now an API. Everything is an API. And everything is now distributed. Whereas before, these policy engines would work in a very specific context and either embedded in a program or working as a standalone and only for that specific program. So policy engines at the time were mostly centralized. And a centralized component in a distributed system, that is a telephone tower. And now you might be wondering, what is a telephone tower? So let me introduce the old Stockholm telephone tower. As Wikipedia describes, in 1887, Stockholm's Allmänna Telefon AB ordered the construction of a tower, allowing the connection of about 5,500 overhead telephone lines. The quadrangular metallic structure was 80 meters tall. Are you all familiar with this? I wasn't, but wow. Historical Photos describes this. Everything that could possibly go wrong did. Oh, that's a surprise. From high winds to ice storms and fires, the network was extremely vulnerable to the elements. And continuing there, it soon fell out of favor with the local population. Who would have thought? The company, and this is funny, so the company requested the architect Fritz Eknert to carry out embellishment work, which was when the 4 turrets were added. So people were complaining, this isn't right. So they were like, okay, let's add these turrets. And of course, we would never do that in this day and age, right? It's not like anyone here ever built turrets on top of a telephone tower or a project where we knew was doomed. So everything is an API. That was one of the things that these men realized. We need a policy engine that deals with that. Everything is JSON. Data is JSON or YAML or what have you, but data is structured. Infrastructure is code. That was another trend of the time. Terraform, CloudFormation, all these technologies were just born. And of course, applications are distributed. Adding to that, and this was part of this, like, do we have to rewrite this policy engine at all these companies? What would we do if this was open source? We could just reuse that. We could add our proprietary modifications or whatnot. But if it's open source, we don't have to do this from scratch every time. So that's the birth of open policy engine. And from here on, I'm just going to say OPA, as we in the game do. And OPA builds on all these principles that I've covered. So policy decisions are now made using JSON as input and JSON as output. We say JSON in, JSON out. Infrastructure as code. Well, you need policy as code. Are you going to deploy thousands of resources or of cloud resources at scale? You're going to want guardrails at scale too. And distributed applications, they need distributed authorization. You can't do authorization using one of these telephone towers where all the lines go point to a single component. And of course, everyone wants open source. So this is OPA. It's JSON in, JSON out, policy is code, distributed authorization, and it's open source. So again, if we go back to this example, it would probably look somewhere closer to this today, where you have a JSON document, which is the query, where a policy, then where you provide that to your policy, it determines whether that should be allowed or not. And the response is also JSON. And this is just an example. So in here, this could be an S3 bucket, or it could be an abstract syntax tree for Rego itself, if you want to build a linter in Rego or so on. So it's a very flexible system because it builds on these very broad and generally applicable technologies. And of course, what was new, we wanted to do this at scale. So I could talk all day about authorization, but well, as was mentioned, I already did. So if you're curious about how what this looks like at scale and how it works, go check out these talks. And of course, any other good resources online. So let's talk about open source, because that was another kind of core aspect of OPA from the start. And in 2018, OPA is accepted into the Cloud Native Computing Foundation, which is, I'm not everyone familiar. It's like the same foundation that hosts Kubernetes, many other of these big projects. One point of this is, of course, recognition. If you're in the Cloud Native Computing Foundation, you get recognition, or you get recognized, because there are many successful, famous projects that are there. Another reason that is perhaps a little more recent than in 2018 would be this. Maybe open source is no longer enough. It doesn't really it provides no guarantees for like future development or governance. And we've seen a lot of these kind of news in the past. I love this. I love the headline there. Redis tightens its license term, pleasing basically no one. That is funny. So the same year, I started to work on developer relations for the company I was at that time. It was not a very glamorous job. I was basically doing developer relations, but internally at the company. So I was traveling around to their offices. I think this is from the one in Tallinn, in Estland, or Estonia, where I found 2 developers. They didn't think they had developers in that office, but I found them. So that was a memorable moment. So we added 2 developers to the head count. It was funny. So not a very glamorous job, but that was kind of my introduction to what I still do today. So believe it or not, we were actually sober in this picture. This is KubeCon Barcelona. This is KubeCon is, of course, Victor mentioned it too. I think it's the flagship conference of the CNCF. And there were several talks there on open policy that had been donated just the year before. And I think this is the first time I hear about OPA. So yeah, that paid off. Donating that to that project, at least for my own career path, because it's turned out like we had been looking for something to solve exactly these problems in that organization I was in then. And evidently, I'm quite happy. And meanwhile, I start getting involved in open source because I'd been coding for a long time, but I really didn't dare to start putting my stuff out there and getting reviewed in public. But we had an issue in Kubernetes that we couldn't solve, and I figured like, hey, I'll try to solve it. And I did, but it took a while. I opened that on January 19, and it was merged on July 9 the same year. Because I had to learn Go in the meantime. So that was quite but it was a good learning experience. And now I had a first commit in Kubernetes, which was pretty cool. And at this point in time, I'm coming back from KubeCon. I'm curious about OPA, and so I started to learn about Rego, which is the policy language that you saw there in passing. So I start writing my first Rego. And Rego is a programming based on logic. Before we do that, I'm going to have to show you this, because when I searched for this picture to use, I found an Easter egg in DuckDuckGo. Did you see that? How cute is that? So, I'm going to teach you Rego now in 1 minute, so you're going to get a sense for what logic programming means. So, this is by no means a comprehensive tutorial in Rego. I implore you to check it out. But these are two of my favorite features that felt very alien to me, and that made them very interesting. I wasn't used to these from other programming languages. So the first one is set, and set is of course a data type, which exists in many languages. It's just not very commonly used. In Rego, it's used all over the place. In case you don't know, a set is a collection of values where all values must be unique, or they're like if you put two of the same value into the set, only one will remain. So it's not an error. It's just going to ensure that the values are all unique, and the order doesn't matter. So if you have 1 and 2 or 2 and 1, it's the same set. So that is the property of a set. And in Rego, it means you can just do RBAC, for example, as simple as this. You have a set of the required roles. You say this endpoint, you're going to need the reports reader and the reports writer role. And the way you check that, if you control which roles are missing, you just take the roles the user has, and you say like the required roles minus the provided roles, the user roles, is equal to the missing roles. So if the missing roles is empty, it's allowed. If there's some missing roles, it's denied. And this is not just, I'm not making this up. This is actually OPA eval doing this, and it looks exactly like this. And this would be a lot more code in the languages I was familiar with. So that was super cool to me, and it still is. The next thing is unification, which is solving equations. That sounds like math, but let's go with it. In logic and computer science, specifically automated reasoning, unification is an algorithmic process of solving equations between symbolic expressions, each of the form left-hand side, right-hand side. That's from Wikipedia. Well, that doesn't seem so hard. It's an equals system. And I know, like, even I know what equals means. So let's do some math with an idiot here. As you might remember from school, this would be an equation. You have something on the left-hand side, and you're trying to figure out like what's y and what's x in this situation. And we're not going to do math, but you could probably think of at least some values here, like 5. If you say 5, y is 5, and x could also be 5. That would be equal. But that doesn't matter. But how would you express this programmatically? If you wrote this in Java or Go, if you wanted to do this, how would you express that? With unification, or the declarative solution, you already did. you express that by expressing the problem, and you have the computer figure out what is X and what is Y. This is a declarative solution to a problem, and that's the basis of Rego. You don't tell Rego how to go out and solve that. You just say, here's the problem, and you figure it out. That's what computers are for. So, difference though is Rego is not built for math, thank God, but for JSON. So if you have something like this, and you say users, and you say 1, what is users, or what would you get? You probably get, assuming we start from 0, you'd probably get Jane. So if we say X, what does it mean? Well, that'll be true for all these users. So Rego goes and figures out what X is. It's going to enumerate all users here. If you do it like this, it's going to enumerate all the roles. And if you do it like this, you'll get all users that has the admin role. So declarative and unification. This was also a concept that to me just blew my mind away, and it still does. I love this. So I truly enjoy working with OPA and Rego. And so after having contributed to OPA and its community for some time, I joined Styra, which was the same company that these guys founded, the creators and the maintainers of the OPA project. And as you could see, or as you can see, I rather liked it there. Even had the pajamas. A few years later, and this was the first year I started out, OPA graduates. So it joins the CNCF, like the highest rank of the CNCF projects, like Kubernetes. And we did a lot of work around this in terms of marketing and so on. So that was one of the first things I got to work on. And of course, weird times for us all. So, a very odd and unusual time to get started doing developer relations when conditions looked like this. The next year, last year, we announced OPA 1.0, which is also an interesting trend in this industry, that the 1.0 release is often done on projects after a decade of development. And for what reasons that is, I guess that depends, and that's an interesting discussion in its own right. But for us, it was mainly just a way to say, like, hey, we have a decade of stuff that we have worked on. We could clean this up and kind of unify what Rego should look like as of now. So how is it all going? We now have policies that are enforced in APIs all over the world. We have hundreds of millions of downloads. We have a huge ecosystem of integrations and tools. We have an active community of users and contributors. I know there's a fair amount of you in this room. And OPA is used in production by some of the largest companies and institutions in this world. And of course, as a month and a half back or something like that, this news broke out as well. Today, we're excited to announce that the creators of Open Policy Agent, along with many team members from Styra, have joined Apple to continue our decade-long mission of delivering an open source solution to unifying policy across the cloud-native stack. Apple is an enthusiastic OPA user, utilizing it as a key component of its authorization infrastructure to manage a vast portfolio of global-scale cloud services. So since a month and a half back, that is what I do. Does it sound fun to you? It sounds fun to me. So I'm happy, and I hope you had a great conference. And cheers to the next 10 years of OPA, and cheers to the next 10 years of Nordic APIs. Thank you.